This is actually kind of the genesis of the deep worker, because we built several of these. These are called sea urchin 2s, and you know, the idea is you lay down, you look out through this front port, top hatch, top dome entry. But it turned out that laying prone like that for a long period of time was very tiring. So you wound up with this one sitting quite a bit of the time. So you'd wind up with your head and shoulders up in this dome, but you could still see down between your knees to the front. And so all the guys that were using, we built 4 of them, said, yeah, it was they never used the light tube because they wound up sitting, but it was kind of cramped. So we got looking at it, thought, well, what the hell? Why don't we just turn this whole thing around? Make this angle greater and just put your legs down there and sit down and look out the top. So if you can imagine this thing turned and twisted, it's a deep worker. Yeah. So I want to build this one for myself because this has a top entry hatch, but it also has where we have the front hatch. What I'm going to do is put a steel hatch on there with 2 holes in it for the exosuit arms. And so what I want to be able to do is fly this around in the normal fashion. We'll cut about this much off the leg tube here, so because we don't need to join that back up. We'll tilt this down in the usual manner, and then you can get to a work site and back up to it, and then just have the seat on a rail that goes up like this, pull the seat out of the way, stick your arms in, and you have a viewport about here.
It's very similar to the Wasp.
It would be, yeah, the Wasp was mostly vertical though. The way the Wasp was designed, it flew from that sort of same 45 degree. I spent a long time in the Wasp. Anyhow, this is deep Roman. This is you can't do any harm in here. This is a 7,000 foot full acrylic, and it was never finished. One of these days I may finish it.
How thick
Single
is
person, 7,000 feet.
How thick is the?
Sorry?
How thick is the?
5 inches. And this was made. This is one of the very first hulls that Stanley Plastic made in England. The deep rover, the one you saw downstairs, that was made in the U.S. By a guy called Bruce Beasley, and it was Bruce Beasley that developed the process for making this particular type of acrylic. At the time that he wanted to make, this guy was an artist, a nice guy, we had good friends. He was an artist, a sculptor, and he wanted to make massive plexiglass sculptures. So he went to the local suppliers, and they said, "Oh no, the most we can give you is 1.5 inches, 2 inch maximum." He said, "I want 2 feet." And he said, "No, I can't do it." So he went to Germany, and he went to Roman Haus, the guys that developed the process of plexiglass beauty, talked to their engineers, and then he sort of pat him on the head and said, "You know, it can't be done. If you understood what you were doing, you know, you'd know why this can't be done." And he said, "Well, why don't you explain it to me?" So they said, "Well, the thing is that when you cast this stuff at exotherms, you know, it does heat. You can't get rid of the heat fast enough to keep it from cracking, because the outside cools, but the inside's still molten. So the inside's bigger than the outside, so the outside has to develop cracks." So I explained all this to him, and he said, "Well, I don't know about that, but I said I want 6 sections." And he said, "How about if I just get plexiglass and grind it up and melt it and pour it?" And they laughed again and said, you know, you don't realize that the melting point of this material and the boiling point are virtually the same. So as soon as it melts, it boils. So it's all over the place. So anyhow, Bruce went back, thought about that for a while, and he said, "Well, okay, if I can't get it, so we got the temperatures that the stuff melts. He said, if I can't stop it from boiling, well, all I can do, why don't I put it under pressure, same as I do in my car? You know, the radiator goes up to 450 degrees in my car. The water temperature is, but the temperature that water evaporates is 212. So why doesn't all the water in my car evaporate? Because it's under pressure." So he bought a hydroclave. Hell of a deal. I mean, talk about ballsy. He bought a whole hydroclave he used to vulcanize tires, and he started putting shavings inside this thing and melting them, and he could melt them. And so he did some castings, and then finally said, "Well, if I actually make this stuff, you know, in the same way that Long and Haas does, I don't have to get rid of the heat as long as it's under pressure. So he got the components of the plexiglass and started casting stuff. So the first major casting he did was a monolithic casting of a wave, huge wave that was for the front of the new town hall in Anchorage, Alaska. And so he got a picture of himself, and this thing's beautifully polished and everything. It was a little more than 7 feet thick, and about 7 feet 2 inches thick, and about 7 feet high. So it's a cresting wave, and he had a bench in front of it. So he got a photographer to take a picture of him reading a newspaper on the other side, you know, through this thing, and he sent it to the engineers in Germany. They immediately came back and said, you know, how did you do this? And he said, oh, very simple, look at my patent. So anyway, he happened to be a mad fanatic collector of Northwest Coast Indian art, and that's where I met him. And it was very wild because this was after we had bought this hull from a company called Palmer Engineering. And he was here at a big show of Northwest Coast Indian art, and I wound up going for supper with him. He knew a bunch of the carvers that I worked with. And so he said, so how is the diving going? I said, oh, you know about the diving? He said, oh, yeah. He said, your submarine? A deep rover? I said, how did you hear about deep rover? He said, I built the hull. What? So, yeah, wow. So, small world and full business, but that's where these big thick castings came from. So all of the acrylic castings of this thickness that are done in the world now use that process, and he gets nothing for it because the patents lapse. He patented far more than 60 years. But interesting. So we've got Santa Claus do this for us. I wanted to build a one-man sub that would go to pretty great depth. The problem was because the material was unknown cyclically, PBHO would not accept it unless well, for instance, a 3,000 foot deep rover is actually has a design collapse of 9,000 feet. So it's 3 to 1, and that's how high it had to be in order for them to accept it. This one is about 3.5 to 1, something like that. So it's designed for 7,000. It's actually something like 17,000. Because it just keeps getting stronger and stronger. I mean, at full pressure, you could hit this with a load of dynamite. It wouldn't bother at all. It's such incredible compression. The big problem is not the wall thickness; it's the seat, of course. And that's the seat wants to see. This material exhibits conchoidal fracture, which is the same thing you see like in the arrowheads. You see the chips out of them, or a spall in your windshield. When somebody hits your windshield and the glass falls off, that's called a conchoidal fracture. This stuff fractures in that mode. So that if you hit it hard enough on the outside, the piece will spall off on the inside.
There's a lot of good photos of that in Jerry's book.
Jerry Stashew.
Yeah.
Jerry and I had a lot of fun. He did the original design for the sub that we were built for Titanic. And, I know Jerry right from day one. In fact, in his book, you'll see a couple pictures of deep workers in there. But Jerry and I had some good, not arguments. We agreed with each other, but we couldn't convince the certifying bodies. We're saying, well, why are we screwing around with all these engineering calculations on hulls? This was long before FEAs. Why don't we just proof test it? Proof test it to whatever you want. You want 2 to 1. Good. Instead of saying 1.4, we'll proof test it to 2 to 1. And they said, it doesn't say that in the book. Yeah, but it makes you crazy. It makes sense, but it doesn't have to make sense. Anyhow, moving right along.